we are going to discuss a topic, Water Quality Index, commonly referred to as WQI. Now, let us first understand why water quality assessment is important. Accurate information on the quality of water is essential to form effective public policies and to implement water quality improvement programs. Without proper data, decision makers cannot plan treatment systems, pollution control measures, or resource allocation efficiently. Now, instead of analyzing many parameters separately, the water quality index simplify this process. It provides information about water quality in a single numerical value. This makes it easier for engineers, policymakers, and even the general public to understand the condition of water. WKI is commonly used for the detection and evaluation of water contamination. It represents the combined influence of different quality parameters on the overall quality of water. Further, WKI indices it can be classified into two types based upon the physicochemical indices as well as the biological indices also. The physical chemical indices are based on the measurable parameters like pH, turbidity, and dissolved solids in a water sample. Whereas the biological indices are obtained from the information such as presence of microorganisms or aquatic life. So, in simple terms, WQI help us convert complex water quality data into a single understandable value. Now, let us move on to the concept of quality of water. Water quality can be broadly classified into three main categories. First one is the physical characteristics. Second one is the chemical characteristics. And the third one is the biological characteristics. Let us first look at the physical characteristics. These includes turbidity, color, taste and odors, temperature, and specific conductivity. Turbidity indicates the cloudiness of water caused by the suspended particles. High turbidity reduces light penetration and affects the aquatic life also. Based upon the color, the pure water usually will be colorless, but the presence of organic matter or metals can impart its color also. And when you look into the taste and the odors, it is caused by the dissolved substance such as salts or organic matter. Usually the temperature affects the chemical reaction, dissolved oxygen levels, and biological activity in water also. And next we are looking into the specific conductivity. This indicates the ability of water to conduct electricity, which depends on the presence of the dissolved ions. So these physical parameters give you a first level indication of the water quality. Next, we will discuss about the chemical characteristics. These chemical characteristics includes total and suspended solids, pH values, hardness, chloride content, nitrogen content, iron content, manganese content, metal content, as well as the dissolved gases. The total and suspended solids will affect the clarity and it may carry pollutants also. Now, the pH value will indicate whether the water is acidic or alkaline in nature. It is a very important parameter for chemical reactions and biological life. Hardness is mainly caused by the calcium and the magnesium salts. Chloride content. If chloride content is elevated, it indicates the possible contamination, whereas the nitrate content includes ammonia, nitrates, which is the important indicators of the pollution. That next, iron content. Excess iron can cause staining and the taste issues also. Manganese content, it is similar to iron, which affects the color and the taste. The metal content, the presence of heavy metals like lead or arsenic will be toxic to human health when it is consumed. The dissolved gases are such as oxygen, carbon dioxide, as well as the hydrogen sulfide. Now, next we are moving to the third one, that is the biological characteristics of the water. Usually, the non-pathogenic bacteria presence in water will be generally harmless, whereas the pathogenic bacteria will cause the diseases in human health. For the aerobic bacteria, it requires oxygen, whereas the anaerobic bacteria will survive without that oxygen also. When you consider about that facultative bacteria, it can survive in both the above conditions. So these biological indicators are very important for assessing the safety of drinking water. Now, let us understand how the water quality index is calculated. In this work, the water quality indexes will be calculated by, that is WQA is equal to summation of the QN into WN divided by the summation of the WN. Whereas Q1 is the quality rating of the nth water quality parameter. W1 is the unit weight of the nth parameter. Now, let us understand the quality rating, that is Q1. The quality rating is calculated by the below formula. That is Q1 is equal to whole of Vn minus Vid, where Vn is the estimated value of the parameter at a given location. Vid is the ideal value in pure water, divided by the whole of Sn minus Vid, where Sn is the standard permissible value and Vid is the ideal value in pure water, which has been already described, multiplied by the 100. For pH, the Vid, that is the ideal value in water, pure water will be pH is equal to 7, where that other parameters also consider accordingly. So this formula basically compares the observed value with the ideal and the standard value and express it as a percentage. This helps in normalizing the different parameters into a common scale. Now let us look at how the unit weight is calculated. The unit weight is the W1. The unit weight is given by W1 is equal to K divided by Sn, where Sn is the standard permissible value of the parameter and K is the constant of proportionality. The constant K is calculated by the formula, that is K is equal to 1 divided by summation of 1 divided by the Sn. So you can basically understand from this formula, the unit weight assigns importance to each parameter. Parameters with lower permissible limits are given higher weight because they are more critical to the water quality. Thus, this weighing system ensures that more significant pollutants influences the WQA more strongly. Now let us interpret the WQA values and their corresponding water quality status in this slide. The ranges are mentioned as follows. If it is 0 to 25, it is excellent and it is suitable for drinking, irrigation, as well as the industrial use. If it lies between 25 to 50, it is good and it is suitable for domestic irrigation and that industrial use also. If it lies from 51 to 75, it is fair and it is suitable for irrigation and industrial use. If the water quality index lies from 76 to 100, it is being classified as poor and it is suitable. It may be suitable for irrigation purpose alone. And if it lies from 101 to 150, it is very poor and it is restricted use for irrigation. If it is above 150, it is unfit for drinking and it requires proper treatment before its use. So if that water quality value, if the water quality index value increases, the water quality gets deteriorated. This classification helps engineers and authorities quickly decide how water can be used. Finally, let us discuss the irrigation water quality indices also. These indices help evaluate whether the water is suitable for agricultural use. These are some of the important indices, that is SAR, sodium absorption ratio, RS in sodium next followed by sodium percentage, and RSC. RSC is the residual sodium carbonate, whereas MHR is the magnesium hazard ratio, KR is the Kelly ratio, and PI is the permeability index. Each of these indices helps a specific formula reference as it has been shown in the table. Now, based upon the irrigation water quality indices ranges, if the sodium absorption ratio lies less than 10, it has been classified as excellent. And if it lies between 10 to 18, it has been classified as good. And if it lies between 90 to 26, it is acceptable. And if it is greater than 26, it is unacceptable. Similarly, if that Kelly ratio is less than 1, it is suitable. And if that Kelly ratio is greater than 1, it is unsuitable. If sodium percentage is less than 30%, it is suitable. If it is between 30 to 60%, it is doubtful. And if it is greater than 60%, it is unsuitable. And if the magnesium hazard ratio is less than 50, it is suitable. If it is greater than 50, it is unsuitable. If the residual sodium carbonate is less than 1.25, it is suitable. And if it is between 1.25 to 2.5, it is doubtful. And if it lies greater than 2.5, it is unsuitable. When you come to the permeability index, if it is less than 25, it is unsuitable. If it is between 25 to 75, it is good, whereas it is greater than 75, it is suitable. These indices are very important in irrigation engineering because poor quality water can damage soil structure and adversely affects the crop growth also. Now we are going to discuss about the distribution of water, which is a very important component of any water supply system. Let us begin with the first point. After treatment, the water is to be stored temporarily and then supplied to consumers through a network of pipelines, which is referred to as the distribution system. So, what happens in a typical water supply scheme is this: water is first collected, then treated to make it safe, and after treatment, it cannot be supplied directly at all times. Therefore, it is stored in reservoirs such as overhead tanks or service reservoirs. From there, it is distributed to household industries and other users through the pipelines. Now, the distribution system is not just pipes. It includes several components such as pumps, reservoirs, pipe fittings, instruments for measurement of pressure, and also devices to detect the leakages. An important point to note here is that cost of distribution is quite significant. It accounts for about 40 to 70% of the total cost of the entire water supply scheme. This shows that how crucial proper decisions should be. Next, the efficiency of the system depends on proper planning, execution, and maintenance. So, even if you are designing a perfect system, if it is not maintained properly, problems like leakage, pressure loss, and contamination will occur. The ultimate aim of the distribution system is to supply potable water to all the consumers whenever required in sufficient quantity with required pressure, with minimum loss, and also without leakage. Now let us look at the requirements of the distribution system. First, they should convey treated water to consumers with the same degree of the purity. This means there should be no contamination during distribution. Second, the system should be economical and easy to maintain and operate because complex system increases the operational cost. Third, the diameter of the pipes should be designed to meet the fire demand. During fire emergencies, large quantities of water are required suddenly. Next, the system should be safe against future pollution. As far as possible, pipelines should not be laid below the sewer lines because leakage in sewer pipes can contaminate the water supply. Another important requirement is that water should be supplied without interruption, even when the repairs are undertaken. This is very important in the urban areas. Finally, the system should be designed to meet the maximum hourly demand. A peak factor of 2.5 is recommended for towns with a population between 0.5 to 2 lakhs, and for larger population, a factor of 2 is considered as adequate. This is about the distribution of water. Now, in practice, there are 4 types of different systems of distribution that are commonly adopted. They are dead end or tree system, gridiron system, circular or ring system, radial system. Each of these system has its own advantages, disadvantages, and suitable applications. The selection of the system depends upon the layout of the town, topography, population density, availability of roads, as well as the cost consideration. In the following slides, we will discuss each of the systems in a detail. Now we are going to discuss about the dead end or the tree system. This system is suitable for irregularly developed towns or cities. In this system, water flows in one direction only into submains and branches. So, if you imagine a tree structure, the main pipe acts like the trunk. Okay, submains acts like the branches. Then smaller pipes will be connected to the submains. So, the diameter of the each pipe decreases at every tree branch. Now let us understand the advantages. First, discharge and pressure at any point in the distribution system can be calculated easily. This is because the flow is unidirectional. Second, the valves required are comparatively fewer in number so that the system is very simpler. Third, the diameter of the pipes used is very smaller and hence the system is cheap and economical. Fourth, the laying of water pipes is very simple. Next, we will look into the disadvantages. One major disadvantage is stagnation of water at the dead ends. This can cause contamination and deterioration of the water quality. Another issue is that during repairs, if the pipes or valves are closed at any point, the entire downstream will be deprived of the supply. Also, the water available for firefighting is limited in quality. So, overall, this system is simple and economical, but has limitation in terms of quality and reliability. Next, let us discuss about the gridiron system. In this system, from the mains, water enters the branches at all junctions in different direction. So, unlike the tree system, here water flows in multiple directions. At any point in the line, the pressure is balanced from two directions because of the interconnected network of pipes. Now, let us discuss the advantages of the gridiron system. First, in case of repairs, only a very small portion of the distribution area will get affected. Second, every point receives supply from two directions and hence with the very high pressure. Third, additional water from other branches is available for the firefighting. Fourth, there is a free circulation of water, so stagnation problem will be avoided. Now look at the disadvantages. More length of pipes and more number of valves are needed, which increases the cost. Also, the calculation of pipe sizes and working pressures are complicated and it is laborious. So this system is more reliable but costlier and complex to design also. Now let us move to the circular or ring system. In this system, supply to the inner pipes is from the mains around the boundary. This system has the same advantages as the gridiron system. Smaller diameter pipes are needed for efficient distribution. Now look at the advantages. First, the discharge rate is high when compared to other systems. Second, the maintenance and repair work can be carried out without disturbing the water flow. Third, due to interconnections, the head loss is minimum. Fourth, since there are no endpoints, stagnation of water is minimal or zero. Now let us look at the disadvantages. This system is not more cost effective because more pipeline is required. Also, more cutoff walls are needed and skilled labor is required for laying the pipelines. So this system provides excellent performance but at a higher cost. Finally, let us discuss about that radial system. This is a zoned system. The area is divided into different zones. Water is pumped into a distribution reservoir located at the middle of each zone and supply pipes are laid radially towards the periphery. Now let us see the advantages. First, the pressure calculations are easy in this system. The layout of roads needs to be radial to eliminate loss of head in the bends. Second, calculation of pipe size is very easy. So this system is simple to design and provides good pressure distribution. However, it requires proper town planning and hence it is suitable mainly for the newly developed areas only. Now we are going to discuss the system of distribution. Now, for efficient distribution, it is required that water should reach every consumer at the required rate of flow. Now, what does this means in practical terms? Every household, industry, hospital, and public facility requires water at a certain flow rate. For example, household tap needs a steady flow. A fire hydrant requires a very high flow. Industries may need continuous supply of water. So the system must be designed in such a way that all the demands are satisfied simultaneously. To achieve this, some pressure in the pipeline is necessary. This pressure ensures that water flows through the pipes and reaches even the farthest and the highest point in the distribution area. Without sufficient pressure, water may not reach the upper floors. Flow may be very slow and supply may become unreliable also. Therefore, maintaining the adequate pressure is a fundamental requirement in a distribution system. Now, depending upon the methods of distribution, the system is classified into three types as gravity system, pumping system, dual system, or combined gravity and pumping system. Each of these systems has its own working principle, advantages, as well as the disadvantages. Now, let us discuss the first type, which is the gravity system. This is one of the simplest and most reliable methods of water distribution. The first point says when some ground sufficiently high above the city area is available, this can be utilized for the distribution system in maintaining pressure in the water mains. So the basic idea here is very simple. If there is a natural elevation such as hill or high ground, water can be stored at that elevation. Due to the gravity, water will naturally flow downwards to the pipelines to the city. This creates pressure automatically without the need for pumps. Now, the second point is this method is also suitable when the source of supply such as lake, river, or impounding reservoir is at a sufficiently higher elevation than the city. So, if the water source itself is located at the highest level, we can directly use gravity to distribute the water. That examples include hill reservoirs supplying nearby towns, dam located at higher elevation. Now the third point is the water flows in the main due to gravitational forces as no pumping is required here. This is the biggest advantage of the gravity system because no electricity is required, no mechanical equipment is needed, and maintenance cost is also very low. Thus, that operation is very simple. Also, it is very reliable because it does not depend upon the power supply. However, this system is only possible when suitable elevation is available. Now, let us move to the pumping system. This system is used when natural elevations is not available. First point, constant pressure can be maintained in the system by direct pumping into mains. So here, instead of relying on gravity, pumps are used to push water into the distribution system. This ensures that required pressure is maintained at all times. However, the next point highlights that important limitation that rate of flow cannot be varied easily according to the demand unless the number of pumps is operated in addition to the standby ones. This means if demand increases, more pumps must be switched on. If demand decreases, pumps must be turned off. So flexibility is limited unless multiple pumps are installed. Now, the next point is supply can be affected during a power failure and the breakdown of the pumps. This is the major disadvantages. If electricity fails or pumps malfunction, water supply will stop over here. And the consumers also will face the shortages. To overcome this, the next point says, hence, diesel pumps are also, in addition to electric pumps, a standby need to be maintained. So, the backup systems are essential. During fires, the water can be pumped in the required quantity by the standby units. This ensures that emergency supply of water. So, overall, pumping systems are necessary when elevation is not available, but dependent on power and machinery and requires proper backup and maintenance. Now let us discuss the combined pumping and the gravity system, which is also known as the dual system. This system combines the advantages of both gravity and the pumping system. First point, this is also referred to as a dual system. The pump is connected to the mains as well as to the elevated reservoir. So, in these systems, the pumps are used to lift water. Water is stored in an elevated reservoir. From that, water is distributed under gravity. Now, the second point is, in the beginning, when the demand is small, the water is stored in the elevated reservoir. So, initially, pumps fill the reservoir. Water is supplied by gravity. When demand increases, the rate of pumping and the flow in the distribution system come from both the pumping station and the elevated reservoir. So, both sources supply water simultaneously. The next point is, as in this system, water comes from two sources, one from reservoir and the second from pumping station, which is referring as a dual system. This increases the reliability. Now, this system is more reliable and economical because it requires uniform rate of pumping but meet the demand variations. So, pumps can operate at a steady rate while the reservoir balances demand fluctuations. Finally, the water stored in elevated reservoir meets the requirements of demand during breakdown of pumps and for the firefighting. This is a very important advantage. Even if pumps fail, stored water ensures uninterrupted supply. Emergency needs like firefighting can be met. So this system is widely used in modern city because it integrates reliability, flexibility, and that efficiency. Now we are moving into the pipe network analysis. Pipe network analysis involves the investigation of the outflow points of the network. Now, what does this mean? In a water distribution system, we have a network of interconnected pipes supplying water to different locations such as houses, industries, public taps, and the fire hydrants. At each of these locations, water is flowing out of the network. These are all called as the outflow points or the nodes. The analysis mainly focuses on two important aspects. One is the pipe flow rate. Next one is the pressure head. Let us discuss about this one by one. Pipe flow refers to the quantity of water flowing through a pipe per unit time. This is usually expressed in liters per second or cubic meters per second. Pressure head represents the energy of a water at a point, usually expressed in meters of water column. It determines whether water can reach a certain height or location. Now, the important statement is the flow rates and the pressure head must satisfy the continuity and the energy equation. This is very important. The continuity equation means at any junction, total inflow must be equal to the total outflow. Whereas the energy equation means the total energy loss around any closed loop must be zero. So, pipe network analysis ensures that water is properly distributed, pressure is sufficient at all points, and the system is hydraulically balanced. This forms a basis for designing efficient water distribution system. Now, let us discuss on one of the most widely used methods for pipe network analysis, which is referred to as the Hardy-Cross method. This method is based on the principle of law of continuity, which states that at any junction, inflow will be equal to outflow. This is the fundamental principle used in that solving pipe networks. And the next point is flow in each pipe is assumed. So initially, we do not know the exact flow distribution. Therefore, we assume a set of flow values that satisfy continuity at the junctions. Now, the next step, a correction to the assumed flow is computed successively for each pipe loop in the network until the correction is reduced to an acceptable magnitude. This means we can start with assumed flows, then calculate errors in terms of head loss, then apply the corrections, repeat the process until the error become very small. Now, the next important relation is if QA is equal to assumed flow, Q is equal to the actual flow, then the correction factor is given by the delta, that is difference between the assumed flow and the actual flow. So the delta will clearly gives you the how much correction is required. Now let us understand that important condition. Around a closed loop, the summation of head loss must be zero. This is based upon the energy equation. Head loss in pipe is generally expressed as H suffix F is equal to K into Q to the power N, where K is a constant depending on pipe properties, Q is a discharge, and N is an exponent. Usually, the N will be taken as 1.85 for Hazen-Williams and 2 for the Darcy-Weisbach equation. Now, in the Hardy-Cross method, the algebraic sum of head loss in a loop will be calculated. The loop is corrected with the assumed flow. Correction delta is found for each loop. Assumed flow in each pipe are corrected. The most important points is the pipes come to two loops will receive both direction with the due attention to the sign. This means if the direction of the flow is same, the the corrections are added. If opposite, the corrections are subtracted. So overall, Hardy-Cross is an iterative method, meaning it is repeated until accurate results are obtained. Now, let us go through the procedure adopted in the Hardy-Cross method step by step. This is very important for problem solving. That is, the first point, the distribution system is divided into two or more loops such that each pipe in the network is included in the at least one loop. So we divide the entire network into closed circuits or the loops. Each point must be part of at least one loop. The second point is assume any internally consistent distribution of flow. This means the assumed flow must satisfy the continuity at the junctions. Sum of flows entering a junction must equal to sum of flows leaving. The third point is compute the head loss in each pipe by equation or diagram. Conventionally, the clockwise flows are taken as positive, anti-clockwise flows are taken as negative. The sign conversion is very important for calculations. Next, with due attention to the sign, the compute the total head loss around the circuit is nothing but that is K into Q to the power N. So for each loop, calculate the head loss, add them algebraically. Next, compute without regard to sign. For the circuit, the sum K Q to the power N minus 1. This step is used in calculating the corrections factor. And finally, apply corrections obtained from the equations to the flow in each pipe. Now, an important point is pipes are common to two loops will receive the both corrections with due regard to the sign. So again, care must be taken for the direction of flow. Corrections must be applied correctly. This process is repeated for all loops until the correction becomes very small and the systems becomes hydraulically balanced. Now we move to the topic rainwater harvesting. Rainwater harvesting is a very old technique of water conservation used in the many parts of the world. In fact, ancient civilizations practiced rainwater harvesting by collecting the rainwater from roofs, courtyards, and the open lands. Even today, traditional systems like tank, strip walls, and ponds are examples of the rainwater harvesting. Now, the second point is rainwater harvesting involves collecting rainwater and storing it. This can be done using very simple systems such as storage water in the tanks or more advanced systems designed for domestic or industrial use. The collected rainwater can be used for domestic purposes like washing and cleaning, gardening and irrigation, and industrial purposes. The next point is excessive tapping of groundwater through the tubers has led to fall in the water table in many parts of the country. This is very serious issue, especially in urban areas like Chennai, where groundwater depletion is common. Therefore, to avoid alarming fall of fall of groundwater table, the aquifer must be recharged by collecting every drop of the rainwater. Now, let us look at the recharge structures. The first one is the percolation ponds. These are constructed for recharging the shallow aquifers. They are about 1 to 2 meters wide and up to 3 meters deep also, which has been filled with boulders, gravel, and the sand. Next, we will look at the trenches. These are all the used where permeable strata are given at a shallow depth. Their dimensions vary and they are backfilled with the filter materials. Next one is that dug wells. Existing well can be used as recharge structures, water is filtered before entering the well. Hand pumps in that areas of groundwater, in areas where groundwater is deep, hand pumps can be used for recharge. Next, we are looking into the recharge wells. These are all specially constructed wells for direct recharge into the deeper aquifers. Next is the recharge shaft, used when shallow aquifer is below the clay layers. Spreading techniques. Water is spread over large areas to allow the natural infiltration. So overall, the rainwater harvesting is essential for the sustainable water management. Now, let us understand how a rainwater harvesting system works. A typical system must consist of the several main components. First is the roof or catchment area, that is the surface where rainfall fall and is collected. Second is the gutters and connecting pipes. These carry the collected rainwater from the roof to the storage or the treatment system. Now we have leaf screens and first flush diverters along with the graded filters. These components removes leaves, dust as well as the debris. So the graded filter typically contains sand, gravel and the pebbles. Next is the storage tank where water is stored. These come from the water treatment system if required. Finally, the water distribution system delivers water to the point of use. An important note, in some domestic system, graded filter may not be used. Instead, a sedimentation tank may be provided to settle dust particles before the filtration. So, the systems ensure that collected rainwater is cleaned, stored, and supplied efficiently. Now, let us study each rainwater harvesting component in detail. The first one is the roof or the catchment area. The rainwater can be collected from roofing. This means that roofing materials should not react with water or release the harmful chemicals. For example, avoid roofs with lead-based paints. Avoid certain composite materials. Some materials like asbestos, concrete tiles, and lead-based paints can affect the water quality at a very high rate. Therefore, non-toxic paint should be used and roofs should be properly maintained. Next one is the gutters and the pipes. These are the conduits carrying water to the storage tank. Their size and slope are very important. If they are too small, water overflow may occur, and if they are too large, can increase it, cost increases unnecessarily. Also, improperly sized pipes can become nesting place for the rodents, that is the rats. So, proper drainage is essential. Next, we are moving into the leaf screens, first flush diverters and the graded filters. Leaf screen prevents leaves and debris from entering the system. They may be simple mesh screens installed at the top of the gutters. Now, an important concept is the first rainfall carries dust, debris. So, this initial dirty water must be diverted. This is done using the first flush diverters. These are small chambers that collect the initial dirty water. After that, cleaner water flows into the filter and storage tank. Now, graded filters are used to remove the suspended particles. They consist layers of pebbles, gravels, and the sand. The efficiency depends upon the size of particles and the depth of the filter. However, finer particles increase efficiency but also increase head loss and clogging effects also. Therefore, periodic cleaning or backwashing is necessary. Now we are continuing on the discussion of the filters. The first part of the rainfall carries maximum impurities, so it must be diverted. First flush diverters help in removing this contaminated water. Typically, about 40 liters per 100 square meters of roof area will be is diverted. After this, cleaner water passes through filters. Now, graded filters will remove the suspended particles. But over time, filters may also get clogged and its efficiency reduces. So the periodical cleaning is required. Backwashing is one of the method where pressurized water is passed in reverse direction. This removes particles which is stuck in the filter media, which ensures the continuous efficiency of the system. Now let us discuss the storage tanks. A good storage tank should have durability, leak-proof construction, opaque exterior to prevent algae growth, smooth interior for easy cleaning. If light enters the tank, algae growth will occur. Obviously, all knows that. Tanks can be made of plastic, concrete, steel, or even fiberglass also. But they must be properly covered to prevent contamination and evaporation, which they should have the manhole for cleaning and overflow outlet. The tank must be underground, or it shall be underground, above ground, or now coming to the water treatment. The level of treatment depends upon the usage. For non-drinking purpose, the simple filtration may be sufficient. For drinking, it requires fine filtration, disinfection. The disinfections can be done by chlorination and the UV treatment. Even after filtration, contaminants like dust, bacteria, and droppings may enter. So, the treatment is essential, and regular cleaning and maintenance are also very important. Now, we will discuss about the distribution system of the treated rainwater in the next session. Thank you.